Hi everyone. In today's lesson, we're going to talk about solving systems of equations in three variables. What you're actually doing when you're solving this type of system is that you're solving for the intersection, if any, between three planes. Now, I want you to think of a plane as a square or a parallelogram. So this is a plane, right? This orange one, and then this green one is a plane, and then this blue one is a plane. So a consistent system has at least one point of intersection. So in this example, there's only one point of intersection. Right here in the middle is where all three planes intersect. We could have the planes intersect this way, right? Where they're intersecting at a line here. Or we could have an inconsistent system where there's no intersection point at all. And here's three examples of where there's no intersection of all three planes. That's the same. Like here's the intersection of the orange and the green, excuse me. Here's the intersection of the blue and the green. And here's the intersection of the orange and the blue, but there's not one point where all three of them are intersecting at once. So our main focus for today is going to be when there is a point of intersection. All right. So here are the steps to solve algebraically. I'm just going to go through them so you don't have to write them down. So here's an example. This is what it looks like when you have a system of three. You have three equations. So I like to call the top equation equation number one, the second equation number two, and the third equation number three. And the way that we set this up is we're going to put equations 1 and 2 here, and then we're going to put equations 2 and 3 here. So let's just take a minute and write them down. So equation 1 is 4x minus 3y plus z equals negative 10. Underneath it, we're going to put equation 2. So 2x plus y plus 3z equals 0. And then over here on the right, we're going to put equations 2 and 3. So equation 2 is 2x plus y equals 3z plus 3z equals 0. And equation 3, negative x plus 2y minus 5z equals 17. So the goal with step 1 is to eliminate one variable. And I'm going to put that we need to eliminate the same variable. So whichever variable you're going to eliminate in equations 1 and 2, you have to eliminate the same variable in equations 2 and 3. Now, it doesn't matter which letter which letter you're going to eliminate. So in equation number 1, let's analyze what we have. So I have a 4x and a 2x. So what that means is I can multiply this equation by 2, and then I'd get 4. Now with the y's, I can multiply the bottom equation by 3, and then I'd get this 3. Or I can multiply the top equation by negative 3, right? And then that would cancel with this one. So I really have three options here. Over here, I could multiply the bottom equation by 2, the top equation by 2, and the z's would be a little bit difficult. So honestly, with this one, you can choose either x or y to eliminate. So I'm going to just go for eliminating y. That's the one that I'm choosing. So eliminate y. So over here, we need to multiply this bottom equation by 3. The reason why we need that is because it needs to match up here. So I'm going to first rewrite the top equation. So I have 4x minus 3y plus z equals negative 10. And now underneath it, I am going to multiply this 3 in. So 3 times 2x is 6x. 3 times y is 3y. And 3 times 3z is 9z. And don't forget, 3 times 0 is 0. So now the goal is to add these two equations together. So 4x and 6x add to 10x. The negative 3 and the positive 3 will cancel. 1z plus 9z will add to 10z. And negative 10 plus 0 adds to negative 10. All right, now let's look at the second equation. So again, we need to eliminate the y because that's what we chose to eliminate. So we would need to multiply this top equation by 2. But you have to think a little bit ahead. 2 times y would be 2y, but it needs to cross off with this positive 2y. So I need a negative, right? I need one sign to be positive and one sign to be negative, just like I had here in order to cancel. So let's distribute the negative 2 and rewrite that equation. So negative 2 times 2x is negative 4x. Negative 2 times y is negative 2y. And negative 2 times 3 is negative 6y, excuse me. And negative 2 times 0 is 0. And I'm just going to rewrite the second equation. And now the goal is to add these two equations together. So first, negative 4x plus negative 4x, plus x is negative 5x. These are going to cancel because they're opposite signs. And then I have negative 6z plus negative 5z, which is negative 11z. And that gives me 17. So step 1 is finished. I eliminated one of the variables. So notice how you went from x, y, z equations to just x and z. So these two equations need to end up with the same variables in order for this to work, which they did. So we have 10x and 10z, negative 5x and negative 11z. So now the next step is that you're going to put these two equations together and eliminate another variable. So we have to write them on top of each other. So we've got 10x plus 10z equals negative 10. I have negative 5x minus 11z equals 17. So it doesn't matter which variable you eliminate, we just have to choose one. So I'm going to try to eliminate the x's because I know I can multiply 5 by 2 and that'll give me 10. And these would be more challenging to eliminate. So if I multiply by 2, let's rewrite the top. So 10x plus 10z equals negative 10. And let's eliminate by multiplying. So 2 times negative 5x is negative 10x. 2 times negative 11 is negative 22. And 2 times 17 is 34. And then we have to add these two equations together. So the 10x and the negative 10x are going to cancel. Then we have 10 plus negative 22, and that's negative 12. And that equals negative 10 plus 34, which is 24. Now to solve, I'm going to divide both sides by negative 12, and z must equal negative 2. So what you've done is you've successfully solved for one of the variables. So now it's kind of smooth sailing. So the next step is that you may choose either one of these yellow equations to plug z into. So it doesn't matter which one you choose. I am going to choose the first one. So 10x plus 10z equals negative 10. So plug into either. So it doesn't matter which one you plug into, I'm choosing the first one. So 10x plus 10 times negative 2, I'm plugging in for z, and I'm going to solve. So 10x minus 20 equals negative 10. Add 20 on both sides. And we get 10x equals 10. And divide both sides by 10, and we get x equals 1. So now you have found a z value, an x value, and the only way to find the y value is to go to the very, very top. So the last and final step is to plug x and z into one of the originals. It doesn't matter which original you choose. So let's go back up to the top and see which one's the best. Really, none of them are, so it doesn't matter too much. I'm going to choose to plug into the second equation. You can pick whichever. So 2x plus y plus 3z equals 0. So I'm plugging in x to be 1 and z to be -2, and I'm solving for y. So 2 times 1 is 2. -2 times 3 is -6. Here are my like terms. So 2 minus 6 is -4 equals 0. And add 4 to both sides, and we get y equals 4. So that is your last solution. Now, technically, you're solving for an intersection point, so you could put it all together as x comma y comma z. So x is 1, y is 4, and z is -2. So that is how you want to finalize your final answer. All right, that's it for today, guys. If you have any questions, now's a good time to jot them down. Otherwise, we'll see you in class tomorrow. Have a good night.